Okay. Hey viewers! Happy St. Patrick's Day. Happy Friday. Whoop whoop. Okay. So today we're going to move on. We're doing chapters 11 and 12 all together. And we're going to look at some solids today. Let's start with the vocabulary. Okay. Polyhedron is a solid that's bounded by polygons that enclose a single region of space. So, anybody know what this is called?
A cube.
It would be a cube if all the sides were regular.
A rectangular prism.
All the sides were congruent.
What?
But since they're not, it's called a, we've got two bases that are parallel.
Rectangular prism.
Rectangular prism. Yeah, the base is a rectangle, so it's a rectangular prism. Does anyone know what this is called? It's, we've got two bases that are parallel, and they have 5 sides. Pentagon, okay, and it's a prism. It's called a pentagonal prism. I hope they can see me. What about these? These are pyramids, right?
Pyramid.
Okay, we only got one base. Okay, this base is actually a square. So, square pyramid. Where's my, that's all I have? All right. Oh, this, muy importante.
Triangular prism.
Smarty.
Right, we got bases, parallel, triangles, triangular prism. Okay, perfect. Oh wait, I keep thinking I'm done. What about this? Okay. Okay. So 6 sides. I mean, it's kind of small. Some of you guys can see it. What? Hexagon. So.
Hexagonal.
Okay, hexagonal prism. All right. So the faces, all these sides, these are called the faces. Okay? All right. Edge are the line segments formed by the intersection of two faces. So these are the edges. They're line segments. Edges. Okay? Vertex is a point where 3 or more edges meet. Vertex, vertex, vertex. Vertex, 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 vertex. Okay? Vertex. Okay. Euler's theorem, Euler's theorem basically says the number of faces plus vertices equals the number of edges plus 2. And you probably won't see this on your SOL, but I'd like to use this if I'm not sure if something is a vertex or not. Okay, is this a vertex? Well, I don't know. Well, if you look at the number of faces, how many faces does this square pyramid have? 1, 2, 3, 4, 5, right? 5 plus how many vertices? Well, we think that's a vertex, but let's just go with it and say 1, 2, 3, 4, 5. Okay, so that's 10. Faces plus vertices 10 equals, let's see if it matches edges plus 2. How many edges do we have? 1, 2, 3, 4 on the base, right? 4 on the base. 4, 5, 6, 7, 8. 8 plus 2 makes 10. Okay, so we're correct. All right, and the base is the polygon that is used to name the polygon that's used to name the polyhedron. Okay. So a regular polyhedron, if you look back on the back of your warm-up, if you look at those 5 platonic solids, okay, and there's the names are underneath them. Okay. Polyhedron whose faces are all congruent regular polygons. Okay, so we've got a name right here. Convex polyhedron is, I drew you a picture here, I know it's not in your notes, and this is concave, okay? But if you extend the side, and this is the same for a regular, remember how we learned about convex, we were talking 2-dimensional polygons, and concave polygons, right? If you took a side and extended it, and it cut through the figure, okay, concave. Same concept here. Concave, okay, convex, convex. Okay, you can read the definition. Cross section, you guys have probably seen in science before. Am I right about that?
Convection?
No? Cross section.
Oh.
You know, when they give you all the rocks, and they show all the sedimentary layers. and they cut it like a cliff so you can see all the different layers. That's called a cross section. Yes or no?
Nope.
Okay. All right, so examples. Prisms and pyramids. Polyhedra. That's plural for polyhedron. Okay? Not polyhedra. Okay? Cylinders, cones, and spheres. I have a sphere. I brought this for my sphere today. I never can understand how people do that. And then they go like, you know what I mean? And then they do like, and for soccer people, like they.
Because they practice.
No, well, maybe it's called juggling. Anyway, we're trying to make this video shorter, not longer. Helping? Okay. So, identify and name the polyhedra. So tell whether the solid is a polyhedron. If it is, name the polyhedron. And find the number of faces, vertices, and edges. All right. Did you guys take a look at your platonic solids?
Yes.
Okay. What does this look like? On the back of the warm-up? Tetrahedron. Like Tetris? Okay. So, go ahead and write that down. I hope I'm on the screen here. Okay, so faces, vertices, and edges. So I'm going to put faces. How many faces? We've got
4.
and then we've got a bottom. 1, 2, 3, and 4. 4 faces. Vertices. How many vertices?
4.
Okay. And how many edges?
6.
Back. It's like 6. Okay, good. All right. What's this called? We've kind of already been over this.
Dodecahedron.
Got it.
Hexahedron.
Hexagonal prism.
How?
I can't spell. Okay. Faces, vertices, edges. How many faces?
8.
How many polygons?
8.
Okay, so we've got 6 around the side and then the top and the bottom. Okay, so that's 8. How many vertices? We've got 6
12.
plus 6. And then how many edges? These are line segments. So there's 6 around the side.
18.
And then we've got 6 and 6. Good. All right. See how this top has a curved surface? What do you think about this? Look at all these examples of that are not
So
polyhedral.
whatever has a curved surface is not polyhedral.
Exactly. I'm just going to write A. Okay. Any questions? Anyone still writing? Done. All right, we can go back later if you'd like. All right, so where's my ball? You take a circle and you cut it through with a plane. Okay, what shape is that going to be that it creates?
Semicircle.
And in this figure, it does kind of look like an ellipse a little bit. But if it's a circle, or sorry, a sphere, and you cut it straight through, it's going to be a circle. Wherever you cut it, you got circle. So, describe the shape formed by the intersection of the plane and the solid. Maybe I can get something else. Actually, I might have something in the workroom, but I could bring it here to show you that. I'll do that. Okay. What about this one here? What's this called, by the way?
Pyramid.
Okay.
Pentagon.
Yeah.
Pentagon.
It's like the second syllable is the first one. Pentagonal. Okay, so this is the pentagon. And what if you take a cylinder?
Rectangle.
Yeah.
Is that a circle or a sphere?
In the figure it looks like an ellipse. What is a circle? All right, so
Something with secret phrase.
secret phrase.
About 108.
Okay, the first secret, does anyone want to create it? Going once, going twice? Okay, first secret phrase is cherry cola. Oh no, it just came to my head. Okay, so let's talk about surface area and lateral area. Take a look at your formula sheet. Okay, here's the formula sheet that that everyone has in front of them, correct? If you lose this formula sheet, just print it. It's on my vision page, and you can just Google geometry SOL formula sheet. Okay? So, right here, this is the exact one you're going to get.
Bacon.
Okay? No. All right, so if you look underneath each of these figures, all right, we've got various formulas. For instance, what's this called?
Rectangular.
Triangular
Prison.
prism. We've got V, that's obviously volume, LA and SA. Okay, lateral area and surface area. Okay, the only difference between lateral area and surface area is that surface area includes the top and the bottom, and the lateral area is only the sides. Okay, so I'm going to show you with a cylinder. This is a net of the surface area of the cylinder. So in order to find the surface area of the cylinder, we would need the area of this rectangle, which is the lateral area, and also the area of the top and the bottom, which are circles. If we just needed the lateral area, we would just be finding the area of the rectangle. Okay, so let's say you were asked to find the lateral area of this triangular prism. Really, it's just the area of this rectangle, area of this rectangle, area of this rectangle. And that's it, just not including the two triangles, top and bottom. Okay, so these formulas go through, and the only difference between the lateral area and the surface area formulas is that we're not including the bases. Okay, capital B, whenever you see this capital B, if you go to the bottom of your sheet under abbreviations, can I make this bigger? Yes. See, capital B is area of the base. That is muy importante para ustedes. Okay, area of the base is big B. Okay, so back to, okay, I just explained that. All right, so we have already written down these formulas to save time, but normally what you would do is you would say find the surface area of the rectangular prism. They tell you it's a rectangular prism. You go to the formula sheet, you find the rectangular prism, you look for it said surface area, so you look for the formula for surface area and you write it down. Okay, so now we go back to that. We already have it written down. Now we are just going to identify length, width, and height. Plug those values in, use our calculator. Okay, so it doesn't really matter length, width, and height. Okay, I don't know. Usually length is longer than width. That's what I'm going to do. So that's a problem. Okay, so notice the formula. Numbers plugged in. L is 5. Width is 4. Height is 10. Everyone's writing this down. Okay? Everyone's got a calculator? Bless you. Okay, so 4 times 5, that's 20. Times 2 is 40. That's 50. Times 2 is 100. That's 40. Times 2 is 80. Somebody's checking my math, right?
220 centimeters squared.
220, we're dealing with surface area. So it is centimeters. Cubed is volume. Volume is how much water goes into this figure. Area is how much wrapping paper we need to wrap this as a present for someone. Okay, so any questions on that one? Okay, number 2, triangular prism. Now this normally we look this way, exactly. When we look at a triangular prism, we see it on a formula sheet, it's this direction. The bases are parallel. Okay, but they've taken it and just kind of laid it on its side. But we still have the triangular bases are parallel. There are the bases, the triangles. Okay, so what this formula says is, okay, height. What's the height going to be?
48.
Now we need the height of not the actual, when we're dealing with the triangle, the base. We need the height of the whole polyhedron. So what's the height going to be?
70.
See? It's the height from one base to the next. Base and height are always perpendicular. Okay, so the height's going to be 70, right? All right, so there's the height. What's P?
Perimeter.
Perimeter. If you're not sure, go to the bottom of the formula sheet and it will tell you. Perimeter is P. Okay. Okay, we're finding the surface area. So basically all we're doing is finding the area of the two bases, which is why there's 2 times big B. Big B is the area of the base. So depending on what shape your base is, you're going to use different formulas. If your bases are circles, you're going to use pi r squared because that's the formula for finding the area of a circle. In this case, our bases are triangles. So to find the area of a triangle, what formula do we use?
Area equals 1.
It's on our formula sheet too, in case you've forgotten. It's in the back, or did I just... here we go. 1/2 base times height. That's what we're going to use in our formula to substitute that in for big B. Okay, let's go back to our problem. Okay, only thing we don't know is perimeter. What's this perimeter? Why is there a perimeter here? Okay, if we're trying to find the surface area of this rectangular prism, we really need to find the area of the two bases and the area of each of these 3 rectangles. So all the perimeter is doing is it's taking this net and opening it up and finding the area of those 3 rectangles all together by using the perimeter, which gives us the width of each of those 3 all together times the height. So it's just finding the area of those 3, the lateral area, all in one term here. So let's substitute. I don't care. If you don't want to use these formulas, I do not care. If you understand what you're doing, you want to find the area of this triangle, or sorry, rectangle, area of this rectangle, area of this rectangle, area of the 2 triangles separately and add them, what do I care? It's the exact same thing. Okay? Surface area. All right. So height is 70. Perimeter is, what's the perimeter? 45 plus 45 plus 51. Okay? Plus 2 times, now the base, big B, is 1/2 BH. 1/2 base times the height. So now we need to find the area. This is just a triangle, and then times it by 2. Okay, so 1/2 base height, perpendicular, 51, 48. Now, you see what happens here. You've got a 2 that's being multiplied by 1/2. So what's going to happen there?
They're going to cancel out.
Okay, that's exactly. That's equal to 1. So I'm not even really looking at that. So now we've got surface area equals, take out your calculator. I got Is this correct? 12,318. Is that right? I just did this yesterday. Okay, and so units?
Inches for.
Good. How are we doing? Any questions? We got a couple more to do. Can I go to the next page? Or is anyone still writing down? Okay. All right, find the surface area of the right cylinder. All right, let's talk about this formula. We've got two different terms here, okay? 2 pi r squared. Do you guys know how to find the area of a circle? Okay, let's say we don't remember. Circle. Underneath the circle, we've got circumference, and we've got area, pi r squared. So, 2 pi r squareds, because we have 2 circles. So this part right here is to find the area of the top and the bottom of the cylinder. This part is the lateral area, which is why on the formula sheet, where's the cylinder? Ah. The lateral area is just this part, 2 pi RH. Why is it 2 pi RH? Talking about this rectangle, right? The formula for area of a rectangle is just length times width or base times height. So the length of this rectangle is just the circumference of the circle. So this is the circumference times the height. Circumference is 2 pi r. We're going to look it up. So the formula is 2 pi r, it's circumference times the height. That's where that formula comes from. Okay? So, have we learned that before? Yes or no? One person said yes. 2 people said yes. Okay, good. All right, let's identify what we're given here and plug in the values. What's this?
Radius.
Okay, so 2 pi 2.8 squared plus 2 pi 2.8. Do we know the height? What am I doing? I'm doing the wrong problem. Someone needs to stop me. Stop me! Radius is 7. I'm like working on the second problem and no one even stopped me. Is that good? Sorry. We'll get to that. Alright, so what I would do is I would write this in terms of pi first, because some of your SOL answers will be in terms of pi. It'll say like 22 pi, 27 pi, okay? So I write this first as this is 7 times 7, 7 squared, times 2. This is 98 pi plus, what is this, 154 pi? For a total of how many pi? We can add those together now. We get 252 pi. It is likely that your answer on your SOL could be written like this. Okay, but you probably at this point might take out your calculator and you might get this right away rather than going through all that. Right? Which is perfectly fine. Okay? Worst case scenario, you're taking your SOL, you don't look at the answers, you don't notice the pi's in all the answers. And then you're like, why is my answer not there? And then you realize, oh, well, the answers have pi in them. You just divide the pi back out. You just did additional work. You multiplied the pi, just divide the pi back out. Okay? So, units, centimeters, surface area, squared. Any questions? Okay, this one. We were given the surface area. Right? So all I did was substitute in what I know. The surface area is 198.8. This is an example of a type of problem where this is one of the reasons behind why we want you to show your work. When we're doing easy problems, like let's say we had to do, I'm going to write in white over the top of this. Okay. Yeah. Okay, 20, I'm just making this up, equals 5 plus 2x or something like that. Okay, so we have a number equals number plus some number times a variable. Okay, that's what we have right here. A number equals, that's a number, plus a number times a variable. Is everybody with me? Okay, how would you solve this from Algebra 1? What would you do first? You would subtract 5, and then you would divide by 2. So here, to find our unknown, our h, we're going to have to subtract that number, and then divide by that number. Okay? It's in our best interest not to round and then use a rounded answer in another calculation. So we'll try not to do that. If I was doing this all in the calculator, it'd be pretty simple, because we could just do 198.8 minus, now you'd have to put this in parentheses. Those will cancel. So 198.8 minus this entire quantity. Okay, and I think I've already figured out, I rounded that. I got one, no. You could write that as 15.68 pi if you'd like. Or you could divide, however you do it, okay? So, when I did that, I ended up rounding because I had to write it on paper to show you steps, even though I wouldn't normally do that, but it's fine. Okay, subtracting those two numbers, you get this approximately equals, now, when you multiply 2 times pi times 2.8, you get 5.6 pi times h. I just, oh sorry, multiply the 2 by the 2.8, left the pi. Okay, so now we're going to divide both sides by all of h's friends, and this is a quantity. So if you do this on your calculator and you're not doing these rounding, that's great. Okay, but just when you divide, there's a parentheses around this entire, I'm dropping things today, this entire denominator. So be careful to add, you have to add those parentheses in. Otherwise, the calculator will divide the 149.54, again, 159.54 divided by 5.6, and then it'll multiply by pi, unless you put those parentheses. Okay, so what are you getting for height, the height there? That's what I got too. Approximately 8.5. Now we found the height, so what are the units going to be? Okay. Not millimeters squared, right? We're not dealing with, we just found the height. We had the area. Surface area.